Welcome back. We are diving into machine learning and we are going to explore the k-means clustering algorithm. In this video, I'll take you step by step through practical example of clustering smart home energy data using IoT. Let's jump right in. First of all, we need to know what is clustering. So a clustering is defined as an unsupervised machine learning model that organizes data into groups called as clusters, and based on the similar different the data points are separated. So basically it tells us the grouping of data which has similar features in one group, which is called as the cluster, and grouping of other data which has similar features in another group. The grouping of one data will differ from the grouping of another data. Now let's jump right inside the coding session. So as you can see, I have imported 4 things here: pandas for machine learning and data visualization, cluster for k-means, and sklearn preprocessing standard scalar, and sklearn.metric silhouette score, and matplotlib for visualization. First of all, we need to load the data. The first thing we need to do is clean the data set. So I'm using here a cleaned energy data set. So we need to use load it using pandas data frame. So in this data frame we will have a various features about smart home energy, but for clustering we only need to focus on independent variables. Now the next one, selecting the feature for clustering. So now we need to select the feature we want to use for clustering. Since clustering doesn't need a target value, we will drop the column of appliances which represents the energy consumption. So data.drop columns is equal to appliances. Data.drop means the column which has appliances will be dropped from the data set. Now we need to scale the data set. This is a very important step because the feature in our dataset may have different ranges. For example, temperature may range from 10 to 40, while energy could be range from 100 to 200. So to ensure all features are treated equally, we need to ensure that all features are treated to normalize them. So I have used a scalar, the function standard scalar, which I have imported up, and then I have given a variable xscaled scalar.fit underscore transform of x. X is the data set we have given here. Now here is the fun part. So now k-means clustering. We need to understand what is k-means clustering. So k-means is one of the most popular and simplest clustering algorithm used in machine learning that aims to divide the dataset into k distinct groups, that is clusters, to ensure that the data points within each clusters are similar as possible. So it is basically splitting the data which has same features into one group and with other same features into another group. That's what k-means is. Now let's come to the coding. So here you can see the exciting part applying the k-means clustering algorithm. We will start at the cluster at 3, and the random state 42 is making the valuable constant in the data set, and we are fitting the scaled data set here. Now we need to give label for the data. So we need to add down labels to our dataset to see which group each data point belongs to. So data clusters is equal to k-means dot label underscore. So with this, every row in dataset which has clusters values indicating its group. Now let's see about silhouette score. A silhouette score is a metric that is used to evaluate the quality of a clustering model. It measures how well the data points are clustered by considering 2 factors, which is cohesion and separation. We don't need to go inside those. So what silhouette score is, it generally evaluates the quality of the clustering model, the model that we have built. It just evaluates how good a model has been created. So we can calculate that by using silhouette score, which tells us how well the cluster has been separated. A score that is indicated to 1 would be for better clustering. So as you can see, I've used the function silhouette score here, x scaled, the scaled data set, and k means label, the cluster labels, and silhouette score, the silhouette average here, and dot 2f. This means that after the decimal points it would show only 2 values. Now visualization. We need to visualize the k-means in order to see how our data has been equally clustered. We will plot the first 2 features on a 2D scatter plot. So that's how the 0 is the first one and 1 is the second one. In Python, the 0th index represent the first value and the 1 index represent the second value. The C is our labeled cluster, and CMap viridis means it's just the color, and S is equal to 30. It shows how big the size is. Now the scatter cluster centers, you can see here X we have kept for 2, 0 and 1. S is 200, the size. C is the red, the size of the center X, and we have given here the marker as X, so it is given as X. So the label I have given here is centroid. The title of it is K means clustering visualization. X label would be feature 1 and Y label would be feature 2, and plt.legend is this, and plt.show is the graph. As you can see, we have given here a silhouette score. The silhouette score is available here, 0.23. Now as you can see, the data points are grouped into clusters, and centroids are center points around which the data has been grouped. That's it for today's video. If you found this video helpful, then don't forget to like and subscribe, and comment below if you have any questions or suggestions. See you in the next video. Until then, keep learning. Thank you.